Okay, we are going to go ahead and talk about speed and velocity. Speed, again, is something that you have heard talked about throughout most of your life. Talk about how fast your car is going, things like that. That is a speed, how fast you can run, those types of things. So, speed measures how fast something is traveling. It is a distance divided by a time. If you look at their equation over here, we've got this Greek letter delta right here. That means the change in. So this is the change in distance. So basically, what that means is that we don't always start at 0. Sometimes, maybe this is 0, but we're starting here, and that's 5. And we run all the way to 10. Well, we didn't go 10 meters or 10 feet or whatever units we're using here. We only went a difference of 5. So it's the change in. The distance changed by 5 whatever, meters, miles, feet, and we'd have to include our units. And then again down here over the change in time. So your stopwatch typically starts at 0, so you go from 0 to 3 seconds, the change in time is 3 seconds. But if you're using a clock on the wall and you start at the 3 and you time it until it gets to the 30, well, it's gone 15 seconds. Okay, so this little delta here simply means the change in time, the change in distance. Sometimes you have to calculate those changes. Sometimes the problem simply gives us the change. The symbol for speed is the letter V, and the units are miles per hour, kilometers per hour, meters per second, basically any distance unit you want divided by any time unit you want. So the next thing we're going to talk about is velocity. Velocity is simply speed with a direction. So just like we had displacement, which includes a direction, so does velocity. Velocity is your speed, but you need to have a direction with it. So how do we say the direction? Well, we could say north, south, east, west, up, down, left, right, things like that. When we're talking about one-dimensional motion, we often say that the velocity is simply positive or negative. Okay, because it's one-dimensional. We're only talking about going left or right or up and down. So if we're talking about going left and right, we say that if we're going right, that's the positive direction. If we're going left, that's the negative direction. Same with similarly with up and down. We say if we're going up, positive direction, down, negative direction. Okay. Now, if we're not talking about just left and right or just up and down, that's not very good. But we're at an angle, then we're going to have to give an angle. Okay, and say what angle we're moving. Again, we've got the symbol for velocity is V. For speed, it was V as well, except it didn't have the hat above it, the arrow. That hat means that it's a vector. It reminds us we need to include the direction. So while we've got the same units, when we give our answer, we need to say the magnitude, our units, and a direction because this is a vector. Velocity is a type of vector. So we've got 60 kilometers per hour going north. This one, you might think, hey, they forgot the direction. They did not. Okay, we would know in the problem whether we were talking about up and down or left and right, and since it's positive, we're either going up or to the right. And then this one over here, 25 meters per second at an angle of 30 degrees. So we know we're going up and to the right at a 30-degree angle above the horizontal. Something else to talk about. We've got instantaneous speed versus average speed. You know this. You know that objects don't always move at a constant speed. Sometimes they are speeding up, sometimes they slow down. It's not always the same. So say we're going along, you're at a stoplight, maybe you're driving here. So we're at a stoplight, we're not going at all, we're stopped, 0 kilometers per hour. And then after so many seconds, we go ahead and hit the gas pedal and we speed up until we get to the whatever we're going to travel at, apparently about 50 kilometers per hour for a while. And then maybe we're getting off the off-ramp, so we have to slow down as we go down the off-ramp. And then maybe we come to a stop at the end. Okay? Our instantaneous speed is different everywhere. It's 0 here. It's 50 here. Somewhere around 30 in here. Okay? The instantaneous speed is different. And the average speed, we can't just take 0 plus 50 plus 0 and average those out. It won't work because we're going 0 for a certain amount of time, we're speeding up for a certain amount of time, we're going 50 for a certain amount of time, and then we're slowing down. So average speed is a little more complicated, and we'll eventually do a problem to practice this. But the average speed is your total distance traveled. So we'd have to figure out how far we went in this section. Pretty easy, didn't go anywhere. How far did we go in this section? How far did we go in this section? How far did we go in this section? Add up all those distances and divide by the total time, which is pretty easy too, because whatever that is, that's our total time. So we've got instantaneous and average. Instantaneous, how fast you're going at any specific instant in time. Average, you need to take the total distance that you've traveled divided by the total amount of time that it took you.